First we consider this differential equation. So for this differential equation, y is the dependent variable and x is the independent variable. And this differential equation contain a this differential equation of first order and first degree independent variable y, since it contain a first order derivative dy dx and its degree is 1. And C, p into y, where p and q are either function of x or constant. So the degree of highest degree of dependent variable is also 1. So we can say this differential equation is a linear differential equation. And also we observe that this differential equation does not contain any term, product of any term dy dx, product of dependent variable and its derivative. Since it does not contain this type of term, so this is a linear differential equation. Now we have to calculate, or we have to solve this linear differential equation. So the solution of this linear differential equation is y equals to some function of x plus some constant. This is the solution of this differential equation. Now for this, first we have to calculate integrating factor. Integrating factor is e to the power integration p dx. And after calculating integrating factor, we multiply the given differential equation 1 by integrating factor. And then we have dy dx plus py into e to the power integration p dx equals to q into e to the power integration p dx. And from here we can write d of y e to the power integration p dx equals to integration this. Now for value of y, we integrating both side, we have y e to the power p dx equals to integration q e to the power integration p dx plus some constant c. So this is the solution. And for solving this type of differential equation, first we compare any differential equation with this form, and then we write p and q, what is the value of p and q, and then we calculate integrating factor e to the power integration p dx, and then multiplying by integrating factor we can write this line directly, that is y e to the power p dx equals to q into e to the power p dx plus c. Then from this integration we have y equals to some function of x plus c, that is c is the arbitrary constant. So this is our required solution. In similar way, we can solve this differential equation. See, this is dy dx plus some function of x into y equals to another function of x. So we can compare this differential equation with dy dx plus py equals to q, and we have p equals to 2x, q equals to this. So we can calculate integrating factor, that is e to the power integration p dx. So e to the power integration 2x dx, so e to the power x square. Now multiplying the given differential equation by this integrating factor, we can write directly y into integrating factor equals to q into integrating factor dx plus c. So here q equals to e to the power minus x square into e to the power x square, that is e to the power 0 minus x square plus x square. So we have only integration dx plus c. So from here integration dx equals to x, thus the y equals to x plus c into e to the power minus x square, and which is the required solution where c is the arbitrary constant. Similarly, for this problem we have p equals to minus 5 and q equals to sin x, and p is constant and q is function of x. So we can compare this differential equation with this, and this is, so this differential equation is linear in y, since this is of the form dy dx plus py equals to q. Now we calculate integrating factor similarly, and multiplying by integrating factor we have this, and for this integration we already know how to calculate this integration. For this integration we consider I equals to this, and then by step we can find value of I, and this is the general solution.